Hello and welcome to the Lesson 4.3 video notes over congruent triangles. Let's get started right away. In the past we've identified and used congruent angles. Now we're going to name and use corresponding parts of congruent polygons, and specifically in this lesson we will prove triangles are congruent using the definition of congruence. Alright, so we've got some new vocabulary. The word congruent, I want you to make sure you have this. When polygons have the same size and shape, we call them congruent. Congruent polygons have congruent corresponding parts. Corresponding parts are parts that match each other, matching places or parts. And so in triangles, we have corresponding angles and sides. Like any congruent polygons, we have corresponding angles and corresponding sides. And so the definition of congruent polygons is this: two polygons are congruent if and only if their corresponding parts are congruent. So in these two triangles, angle A is congruent to angle H, angle B is congruent to angle J, and angle C is congruent to angle K. Then AB is congruent to HJ, BC is congruent to JK, and AC is congruent to HK. And therefore, these triangles are congruent by definition. And so we say triangle ABC is congruent to triangle HJK. Notice that these corresponding letters match up in the correct place. A and H are the congruent angles, so they should both come first in the label. B and J are congruent, so they should be in the middle. Then C and K at the end, because those are also congruent. When you name a polygon, you want to list the vertices of a polygon in consecutive order, either clockwise or counterclockwise. Alright, if you have those written down, we can move right along. Alright, in your diagram, if you want to pause the video to copy these down, that's fine, but I'm going to go through this kind of quickly. In these two congruent polygons, their corresponding parts are going to be congruent. So the corresponding angles would be G and P, Q and F, or F and Q, sorry, E and R, and D and S. Then the corresponding sides are GF and PQ, FE and QR, ED and RS, DG and SP. Since all the corresponding angles are congruent and corresponding sides are congruent, we say that these two polygons are congruent like this: GFED, PQRS. That order is very important. G corresponds to P, F corresponds to Q, E corresponds to R, and D corresponds to S. And then specifically in triangles, we have these triangles here where angle J is congruent to angle P because they are both the 52-degree angles. Angle K is congruent to angle M because they're both 78 degrees. And angle L is congruent to angle Q because they're both 50 degrees. Then we have sides that match up: JK and PM. JK is 39, PM is 39. KL and MQ, they're both 40. And KJ and QP are both 50. So we would say triangle JKL is congruent to triangle PMQ. Alright, we know what a conditional is, and we should know what the converse is. Converse is where we exchange the if and then parts. So we have this conditional: if all corresponding parts of polygons are congruent, then the polygons are congruent. So the converse is if polygons are congruent, then all corresponding parts of the polygons are congruent. Alright, pause the video if you need some more time to copy these things down. And once they're copied down, we should be ready to go. So let's take a look at this first example. I know it's called example 2, but this is the first one we're starting with. Alright, it may look like this is completed, but you'll notice there's some missing pieces. In this diagram, we are given that these two triangles are congruent. ABC is congruent to DEF. If you're ever not sure which angle would correspond to angle A, go back to the label. Angle A must correspond to the first letter on the other side of the congruent sign. A and D should go together because they're both first. That means B and F should go together, and C and E should go together. And so this works out nice because we've positioned these triangles in the same kind of orientation. So it's easy to see that A and D go together, B and F go together, and C and E go together. But remember that their corresponding sides are also the same. Now, in order to do this, you need to understand something. This acronym, CPCTC, we're going to come back to that later on, and it just means corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. CPCTC. We will come back to that quite a bit in this chapter. All right. So by definition of congruence, then the measure of these two angles has to be the same. And so what we are supposed to do is find x and y. To find y, we're going to use that angle measure. So by substitution, for the measure of angle F, I'm going to replace that with 8y minus 5. And for the measure of angle B, I can replace that with the 99 degrees. Then we simply add 5 to both sides, and we get 8y equals 104. And dividing both sides by 8, y then equals 13. All right, once again, we're going to start off to find the value of x now, which is a side measurement. So we're going to compare FE to its corresponding side, BC, and they're congruent by this reason. Corresponding parts of congruent triangles are congruent. So we substitute in their equal lengths, and then we substitute the values 2y plus x and 38.4 for BC. So 2y plus x equals 38.4. Now we know what y is now. We know that y is 13, so I'm going to substitute that in for y. 2 times 13 plus x equals 38.4. And we're going to simplify by taking 2 times 13 and getting 26, and subtract 26 from both sides, and then we get that x is 12.4. All right. Let's move right along. Now we are going to get into some proofs, and we'll get to that in just a second, but let's look at this theorem, the third angles theorem. So if I've got two angles of one triangle that are congruent to two angles of another triangle, the third pair of angles have to be congruent. So we would know that angle A has to be congruent to angle L. And this is really easy to see once we prove this. So we're going to go through this proof. Parts of it are already given to us, but we're going to go through and work this out together. So please pay attention. So here's what we have. Our given information is that angle C is congruent to angle K, angle B is congruent to angle J in this diagram here. Now notice that's not what we start with. But we do start with the fact that angle A, B, and C add up to 180, and J, K, and L add up to 180. That's not given. That is your triangle angle sum theorem from last lesson. Then by substitution, we can say this. Measures of angles A, B, and C should add up to the same as measures of angles J, K, and L. We substituted this value in for 180. Now we go ahead and talk about our given that angle C is congruent to angle K and angle B is congruent to angle J. Then their measures are equal by definition of congruent angles. And then we can take a look at this. Since C is congruent to K, I can replace the measure of angle C with measure of angle K. And since B is congruent to J, I can replace the measure of angle B with the measure of angle J. And so you notice that we have measure of angles J and K on both sides of the equation by substitution. And then we can simply subtract those two from both sides and get the measure of angle A equals the measure of angle L by subtraction property of equality. And then there's missing a step here, so add in step 7. Because their measures are equal, I can say angle A is congruent to angle L by definition of congruent angles. All right, so that's just a quick way of showing you that the third pair of angles in any two triangles are congruent if we know that two triangles of one are congruent to two angles of one are congruent to two angles of the other. All right, so let's try and do a proof here. We're going to take a look at proving that two triangles are congruent by using the definition of congruence. Now, in order to use the definition of congruent polygons, we have to show that three corresponding angles of one triangle are congruent to three corresponding angles of the other. We have to also show that there are three pairs of corresponding congruent sides. So really there are 6 things we have to be able to say. Now what we'll notice is the given information takes care of a lot of that, and so I'm going to make just a little tally. I should have 3 tally marks for pairs of congruent angles and 3 tally marks for pairs of congruent sides. Once I have 3 of these, I can say my final statement that the triangles are congruent by definition. Okay, so let's look at what we were given first. All of the given information is not included in that first statement. So we will come back to the rest of that given in just a minute. But if I know that DE is congruent to GE, there's one pair of congruent sides. And DF is congruent to GF, there's another pair of congruent sides. The only other side of each triangle is this side EF, which is shared by both triangles. Well, EF is obviously congruent to itself by the reflexive property. So there's my third pair of congruent sides. Now I can talk about the angles. I can go back to the rest of the given information. Angle D is congruent to angle G, and angle DFE, this angle here, is congruent to GFE, this angle here. Those are both given to you. Well, since I have 2 angles of this triangle congruent to 2 angles of this triangle, the third angles theorem states that the third pair of angles are congruent. That would be angle DEF is congruent to angle GEF. Well, let me recap. There's one pair of congruent angles, there's the other pair of congruent angles, and the third angles theorem gives me my third pair of congruent angles. So I've got 3 pairs of congruent angles, 3 pairs of congruent sides, so the triangles are congruent by definition. Alright, why don't you take a try at proving that these 2 triangles are congruent by definition. Remember, we need 3 pairs of congruent angles and 3 pairs of congruent sides. So use this to keep track of your 3 pairs of congruent angles and sides. Make 3 tally marks here and 3 tally marks here once you've said those things in the proof. Go ahead and try and fill these in. When you're ready to go on, we'll check our answers. Alright, this is what we should get. Alright, we're given all this information, and we have in that given information 1 pair of congruent angles, so I made a mark there, 1 pair of congruent sides, so I make a mark there, and another pair of congruent sides. Now notice I've gone ahead and made the third mark because I've included that after this statement. The rest of the given information is that L bisects KM. Well, that tells you L is the midpoint, and because of definition of segment bisector, that means KL is congruent to ML. So I want to state that. There's my third pair of congruent sides. Then I can go to talking about these angles, JLK and PLM. JLK and PLM are those 2 angles with a vertex at L. Those are congruent because they're vertical angles by the vertical angles theorem. So there's a second pair of congruent angles other than the given. And because I now have 2 pairs of congruent angles in both triangles, I know the third pair of angles, K and M, have to be congruent by the third angles theorem. That takes care of 3 congruent angle pairs and 3 congruent side pairs, so the triangles are congruent by definition. Alright, we have another theorem and some more proofs to do. We're actually going to save these proofs, and we're going to do these in class. If you want to make an attempt to try and do them, you're welcome to, especially the last one. The last example, I've given you all of the proof. You just have to put that into a 2-column and a flowchart proof. So if you want to go ahead and take a look at those, you're more than welcome to. Otherwise, we will talk about these last examples in class on our block day.